Welcome to In 5 Minutes. In this video clip, we will start the discussion on double sideband full carrier generation. We will discuss important circuits which generate DSB-FC signal. In the process of generation of DSB-FC, please remember that we will be using two signals. One is my modulating signal, which is low frequency signal, and the second is my carrier signal, single and high frequency signal. And the output of the circuit will be DSB-FC signal, which is in the form of original carrier and two sidebands, which are called upper and lower sidebands. Before we start with those circuits, we need to understand few important things. For example, tank circuit is one of them. Let's try to understand what is tank circuit, how does it work, and why do we need it in the generation of DSB-FC. So tank circuit is nothing but a simple connection of a capacitor and an inductor. Let us first assume that capacitor and inductor are ideal in nature. In that case, as we know from network theory, none of the components, inductor or capacitor, will consume any power, and hence the total power dissipation in the circuit will remain equal to zero. Let us discuss the working of the tank circuit in a situation where I have charged one of the two elements, which means that we have taken a capacitor which is charged to some initial voltage, let me call it Vc. Before it was charged to Vc, let's say its initial voltage was equal to 0. So in the charging process, the voltage across capacitor will increase from 0 to the maximum value of Vc. Now, moment you connect the charged capacitor across inductor, you can easily see that there is a closed path available, and capacitor, due to this reason, will start discharging through inductor. Let me assume that initially inductor is not charged, that means it does not have any initial current. It is totally uncharged, and hence while capacitor is discharging, that means while there is a discharge current flowing in the loop in this particular direction, this discharge current will start charging the inductor. So we are discussing the stage of the operation in which capacitor is now discharging through inductor, and in this process the inductor will start charging. So if I keep on recording the voltage across capacitor, I will see that now the voltage across capacitor has decreased because it is discharging, and from maximum value of Vc, the voltage comes down to 0 again. But please remember that this discharge, which results in 0 voltage across capacitor, does not mean that there is no energy left in the circuit. The entire energy which capacitor possessed when it was fully charged is transferred to the inductor now. It stores the energy in the electric field, and once the energy gets transferred to the inductor stores the energy in magnetic form. Now the inductor is fully charged and capacitor is fully discharged. Inductor cannot retain that energy with itself because there again exists a closed path in which capacitor is uncharged, and it is now ready to receive the energy from the inductor, or it is now ready to charge, in other words. So immediately after capacitor has transferred its entire energy to the inductor, inductor will now start discharging. So when inductor starts discharging, it will force current in the same direction in which the inductor was charged earlier. The discharge current of inductor will flow in the clockwise direction. When this discharge current is flowing in the clockwise direction, in other words, when the inductor is discharging, in this process capacitor will start charging. So when capacitor starts charging, if you observe, because the current is flowing in upward direction, this time the charging polarity will be opposite to the previous one. If I record the voltage across capacitor this time, the capacitor is charging, but as we can very easily make out, the capacitor is charging in the reverse direction. So let's say inductor completely discharges, capacitor will charge completely to the same value of Vc again, because we have assumed ideal components, there is no loss of energy. So entire energy is now transferred to the capacitor. The same process will repeat. The capacitor is fully charged. It will not retain the energy with itself. It will start discharging. Now this time when capacitor discharges, let us note this, because it is charged with the opposite polarities, this time the discharge current will flow in anti-clockwise direction. So when the discharge current flows in the anti-clockwise direction, capacitor is discharging and inductor is now charging. So if I record the voltage across capacitor again, it is discharging and its voltage will come back to 0. So capacitor will give away the entire energy again to the inductor. Inductor is fully charged, and as you can see, this process will keep on taking place. So if we take couple of more observation, we will get the sinusoidal signal across the capacitor, and this sinusoidal signal represents the nature of the voltage, which is simply the charging and discharging, and then charging in the reverse direction and discharging again. So that's how the tank circuit operates.